Guys, welcome. That's less than nine. So anyway, I want to go over what we did the last time, which is, how do you call it? Powers of natural numbers, or what some books would say, powers of numbers. Okay. We want to look at that. I want to all over again. Once I'm done with that, the last time or whatever I was saying, since it's just 1 hour, go over some of the pick one of why we've migrated the last two. Our goal is to get home, actually watch by here. It also gives you action that. So if you are here, kindly say good morning. If you are here, kindly hi or something. Not wasting time. Some of the crowd. Huh? Let me know if you can hear me. The mic is breaking. Is it true? Mic is breaking. Is it breaking? Is it breaking or it's okay? It's breaking. So just give me some. Just change. Just give me some. Let me know. Yes, please. So yes, please. Asking it better or still break. So I'm not getting a response. So can you let me know if it's breaking? It's still breaking. Wow. Okay. Laptops. So using the laptop's mic, is it okay? Using the laptop's mic, is it okay? Can anyone hear me? Okay, so then it's from the mic. Fantastic. So we can go in. Okay. And there's no noise attached to it. Okay, so then let me just use the laptop's mic. Okay, so today we want to look, as I said, the goal is to look at some rules. So we are actually looking at rules in relation to indices. Okay, now indices is basically the plural form of index, and it is in reference to powers of numbers. Okay, so the lower side or some textbooks name it powers of numbers or powers of natural numbers. And then if I have A and then X, the X is an index of what? A. Okay. So the X is an index of A. A is termed as what? A base number. Okay. A is termed as a base number. Now, there are two popular rules that I believe everyone knows. So the other two is what you're going to concentrate on, and some other rules that are going to help us solve some of the complex questions. Okay, but let's just quickly go over some of the basic rules that we are comfortable with. The first one is if I have the same base number with a power, multiplying the same base number with a different power, the powers, once the base numbers are the same, the powers will add since it is multiplication. So that is a very basic one. Okay, fantastic. No noise. Thank you very much for that feedback. If I also have the same thing, but this time around the operation between them is division, then it means that the powers are going to subtract. Okay. Now there's also another one. If the thing is raised to the power 0, okay, that is equal to what? 1. If the thing is raised to the power 0, it is equal to. Okay, so these are some of the rules, but we'll quickly just dive deep and take one question, which is a bit complex, and then we'll see how best we can actually solve it. Some of the complex questions that you would normally get will be this type of question. So I'm just going to go to a new screen and then look at that. So a very typical example is 2 raised to the power, or 2 raised to the power 9x minus 3 being equal to 8 raised to the power 3 minus x. Now with this one, we have to find the value of x. So finding the value of x, the best thing we could do here basically is ensuring that the base numbers are the same. Okay, ensuring that the base numbers are the same, what we need to do is that we have to concentrate on the smaller number. So we want to find out the smaller number raised to what power will give us the bigger number. So the smaller number here I'm referring to is the 2. 2 raised to the power what to give us 8. So let's find out. Now 2 times 2 times 2 is obviously going to give us 8, or we all know will give us 8, or at least some of you know. So it basically means that 2 raised to the power 3 is the same as 8. So we are actually going to replace this 8 with 2 raised to the power 3. Okay. Now remember that there's already an index here. Okay. So we are going to put that index in a bracket quickly. You can also decide to put this one also in a bracket. It doesn't change the value. Okay. So once we've established that 2 raised to the power 3, okay, to exponent 3. Sometimes the word is changed to exponent. Okay, exponent is the same as being raised to the power. So 2 exponent 3 or 2 raised to the power 3 is the same as 8. So we are going to replace the 8 so that we can get a base number that is the same, since this is actually an algebraic equation that has been fused into what? Indices, okay, or powers of numbers. So the next thing is actually rewriting the whole thing. As I said, if you put in a bracket, it won't really change it. So it becomes 3. Remember, this was already there and it's in a bracket. So 3 minus what? X. Okay. Once the base numbers are the same, it means that let's just imagine that it will cross out. So it goes off and then it gives us what is on top. It ensures that whatever is on top, which is the power, becomes linear. Okay. So have 9x minus 3. You can still decide to put in a bracket. It won't really change. 3 into bracket 3 minus x. Okay. So this one, let's say 1 is in front of it. So when we expand, it won't change the value. But with this one, 3 is in front of the bracket. So we have to do some form of more. Okay. So 3 will give us 9. Positive, negative will give us negative 3 times x will give us 3. Then we'll end up grouping like terms. So grouping like terms, the poor man, which is the negative 3, will go to the rich man, which is the 9x. Okay, so it becomes 9x plus what? 3x equals 9. This also is what? Negative. So it comes here, it becomes what? 4. Okay, so having that would have 12 as an answer. This place will have 12x as an. Okay, so quickly you just have to divide both sides by 12. You don't need to cancel to show that your answer is going to be 12 over what? 12. Okay, and we all know that 12 over 12 is the same as what? 1. Anything dividing itself is the same. So this will give us 1. Okay, so basically that's our answer. Now, the meaning of this answer is if I decide to pick this answer 1 and fix it here, okay, if I decide to fix 1 here, that's going to give me, let's just do it. So 2 into raised to the power 9 into bracket 1 minus 3 equals what? And I decide to do the same thing. I should get the same answer on both to ensure that this equal sign that I've placed there is verified or is justified. So if I fix that here, I should be getting 2 raised to the power 9 minus 3, which is going to give us 6. If I also decide to fix that one here, okay, and I do that, or I even use the 8, okay, 8, and then I have 3 minus 1, which will give me 8 raised to the power 2. 8 times 8, and then 2 raised to the power 6 should give me the same answer. So you can later check and find out what answer that will give you, and you'll be surprised that it will be the same answer. So we're going to have 1 hour. I'm moving a little fast, a little bit faster, so that we can cover a lot with the shortest possible time. This is also an interesting one. So look at this. We have 64, which is actually an answer to one of the things we just did. 64, 5 over 6. Okay. 64, 5 over 6. Okay, so once we have this, now, but this one is also related to powers of natural numbers. Okay, this is also related to powers of natural numbers. Now, what do? The goal is to actually get something that will cancel this. Okay, so that you have a whole number, not a fraction. That fraction can be used to resolve this. So we are going to take the bigger number, and we are going to find out if we can get a number raised to the power 6. Okay, a number raised to the power 6 to give us 60. And when we do our 2 times table, we can actually multiply 2 6 times. This is 1, 2, 3, 4, 5. So the last one. So 2 times 2, 4 times 2, 8 times. So so on and so forth. 32, 32 times 2, that's going to give us 64. So 2 raised to the power 6 will do the job for us. So we are going to replace this 64 with what? 2 raised to the power 6. Okay, then we have 5 raised to the power 6. Now, because of the brackets, this 6 will be multiplying the power here. Okay, because it's also a power. So it becomes 2 raised to the power 6 times 5 raised to the power 6. Okay, now if we should just capture this multiplication of fractions, it basically means 6 times what? 5 divided by 6. This 6 is also divided by 1. So this 6 can cancel. At the end of the day, it becomes 5 raised to the power 5 divided by 1, which is the same as 5. So the whole thing becomes 2 raised to the power 5. So with that one, we can all get the answer to be 30. 32. Okay, so this is also another type. Okay, it's a bit complex, but when you look at it closely, it's not so difficult, if I should say. Okay, then we have another type, which some of you would say that. Now, before that, there's also a rule that's going to help us solve a new type that's out of. The rule says that if I have a raised to the power negative 1 or negative x, a raised to the power negative x is the same as 1 over ax. What it means is that if I should have 2 raised to the power negative, then it is the same as 1 over 2 raised to the power 3. And that will give me 1 divided by 2 times 2 is 4 times 2, 8. So 1 over 8. Okay. So sometimes you can get you can be given this, but in a nutshell, they are actually referring to it as 1 over 8. Are we okay? So that's also one rule you should keep in mind. And that rule, we can use it to solve a lot of questions when those kind of questions are presented. Let me see if I can get a question that is related to this rule I just placed on the board, and then we can actually do or solve that. So I'm not really okay. So yeah. So basically that is it. Now, what if this same rule is fused into a question that has a lot of decimals? So let's look at a typical example. An example that I know most of my students will run away from, but let's just do it here, and then in case it presents itself, we're confident in that. So we have this 1 over 3. Okay. So we have 0.064, all raised to the power negative 1 over 3. The first thing you need to do is getting rid of the decimal. You really get rid of the decimal, but you're just going to change it. Changing it will basically mean that a decimal can easily be changed to what? A fraction. Okay, a decimal can easily be changed to a fraction. So changing this decimal to a fraction, let me just explain the concepts surrounding changing a decimal fraction. So if assuming I have 1.5, okay, let me just make it maybe 0. In any decimal, so let me just use 0.2 is over 1. So if I flip the dots out, I'd have to add the 0. Okay. Now, when we take this 0.065, basically means that if I'm going to flip, I'll flip 1, 2, 3. Okay, so I have to add 3 zeros here. Already, we know that is 1. Every number is divided by 1. Every number which is not a fraction, every whole number is divided by 1. Whole number is the same as that same whole number divided by 1. So if I'm going to flip the dots out, it means I need to add 3 zeros because I flipped the dot out 3 times. Okay, so this whole thing, 0.064 is now 64 divided by 1,000. Okay, so we'll put that in the brackets and we'll place the index there. Okay, so once we've done that, the next thing we need to do quickly is to do some form of reciprocation in order to get rid of the negative. So another rule I want you to pay attention to is that if I have a over b, all raised to the power negative 1, in order to not to do this whole fraction thing, I can decide to change or reciprocate. Okay, reciprocate the a over b to become what? B over a. And when I do that, I'll end up getting 1. So the negative goes away when I reciprocate. Okay, the negative goes away when I reciprocate. So someone has a question. Yeah, so you can get a question. Someone is saying that, can you get a question where it will be a raised to the power negative 2. Yeah, so you can get a question where it is, you can get a question where there are a lot of negatives. So the example that I'm doing right now is actually a typical example where there can be a variable attached. Now, when a variable is given to you, it means they are going to equate it to and something, which means it's going to be in form of an equation, especially if they want you to find the value of the variable that has been presented in the question. Okay, so something like this, the goal is to change this so that we can get a positive. And as I said, negative index, especially if the thing is a fraction, even if it's not a fraction, negative index, once you reciprocate whatever is there, the negative goes away. Okay, so let me just do another example. Assuming I have maybe 2 raised to the power negative 4. Okay, and I don't want to work with a negative. I don't also want to change it to a fraction like this. A fraction like this is one way. Another way also is to reciprocate this. So this becomes, it's actually the same thing. So this becomes a reciprocation. So you know that 2 is actually 2 divided by 1. Okay, so if I decide to reciprocate, it becomes 1 over what? 2. The negative goes away the 4. So you realize that it is the same process, but there are two ways to do it. The first time I didn't explain it to you. This time I'm explaining it to you. Reciprocation. We get the 1/8 through the process of reciprocation. Okay, so once we have this, we are going to reciprocate the 64 divided by 1,000. So now it becomes what? 1,000 divided by 64. Okay, so 1,000 divided by 64, the negative goes away. Okay, so once we are done with that, the next thing we are going to do is to use this opportunity to get rid of the, how do you call it, the 3. So the goal is to get rid of the 3 so that this index does not become a fraction. We are trying to get rid of the denominator of that index so that the index doesn't become a fraction. Okay, so Romain is also asking a question again. So please, how will you change it into a fraction? Like, will it be 2 over ax? No, it will be 1 over x, 1 over a raised to the power 2x. So let me finish with this one, then I'll sort your question out for me. So the goal is to get rid of this 3, which is the denominator. To get rid of this 3, we need a 3. So if I go to the previous screen, you realize that to get rid of this 6, okay, we needed something, a 6 that can come and cancel because of the bracket. Whichever index we get here will be doing some form of multiplication and we'll end up removing that denominator for us. So it's the same principle we are going to apply. And in this case, we have a fraction. So we are going to find out what raised to the power 3 will give us 1,000, what raised to the power 3 will give us 64. Now, when we look at it closely, 10 raised to the power 3 give us 1,000. 10 raised to the power 3 basically means 10 times what? 10 times what? 10. Okay, 10 times 10, 100 times 10, 1,000. Okay, then we also want to find out what number raised to the power 3 will give us 64. And that number basically is 4. Okay, so 4 raised to the power 3 will give us 64. For 16 times 4 is 64. Okay, so over what? 4 raised to the power 3. Okay, once we have this, okay, we are not done. The goal is to make that 10 raised to the power 4 have a single what? Index. Okay, so I'm going to explain this again now. So please, after we are done with this class, maybe tomorrow or over the weekend, you can come back and watch this, because there's a lot of things I'm talking about that you don't really pay attention and then you are just living in the moment, you know. So please come back and watch the video again. So after we are done with this, there's also another principle I want us to know. And that principle basically says, if I have a raised to the power x over b raised to the power x, it is the same as a over b all raised to the power what? X. Okay, which means that if I have 2 over 3 raised to the power 2 or index 2 or exponent 2, it's the same as 2 raised to the power 2 divided by 3 raised to the power 2. Okay, so it's the same principle we are going to apply, but in this case we are not actually going to change it to this, but we are reversing it. So this 3 and 3 will come out, which will mean that it is going to be 10 over 4 raised to the power 3. Remember, this was already there. So times what? 1 over 3. Okay, so once we are done with that, it brings us to what we did previously with the second example. So if I should go to the other screen, this is the second example. Realize that we get the same fraction. Okay, the fraction we had here, we get the same fraction because it will give us the opportunity to cancel the denominator. So let's look at that. So now this basically becomes, sorry, let me just write on the new screen. So this is what we got to. 3, 1 over 3. And I said, I actually explained it that if you have a over b all raised to the power 3, the same as a raised to the power 3 over b raised to the power 3. So with this one, we're actually doing the reverse form. So now it becomes 10 over 4 all raised to the power 3. Because this 3 is coming out, and to multiply the fraction that is there. Now we are going to pick this and work on it. Okay, so 3 times what? 1 over 3. This 3 is over 1. So we will cancel and the 3's will go. This will give us 1 over 1, which is plus 1. So now it is 10 raised to the power 4 or raised to the power 1. Anything raised to the power 1 is that same thing. So our answer is 10 raised to the power 4. Our fractions are supposed to be in their lowest possible term. So if we have 10 over 4, it means 2 can actually break down or cancel that. So 4 will go here 2 times, and 4 will go here 5 times. Times 5 over 2. No one should rush to say I'm going to change this to a decimal, unless maybe the question demands that you should change this to a decimal. Okay, so please let's take note of that. Let's take note of that and do the right thing. Okay. Okay, so we're going to take another question. We're going to take this question. Actually, I'm going to introduce square roots. Square roots. There's a reason why it is called a square root. We have cube roots and we have different types. Okay, by your level, we have to concentrate on square roots. Okay, so so I didn't answer Romaine's question. So Romaine is saying that if you have a raised to the power is a negative 2x, what will it be? So a raised to the power negative 2x basically is going to be the same thing, because if you're applying the principle where a is going to be over 1 raised to the power negative 2x, and we want to get rid of the negative, we are going to flip it, so it becomes 1 over what? A. This negative is gone, but the 2x will still be attached to it. This is 8, it's not 9. Okay, so basically this remain your question, that's your question, that's the answer. Okay, so the 2x will still be attached there. Just that it becomes 1 over a raised to x. Okay, fantastic. So because we started 6:10, no, we started 6:30. Oh, okay, so I thought we started at 6. So we'll be closing very soon. Just stay tuned and let's finish. So we're going to take another question, which, as I was saying, it involves this sign, which is what the square. Okay, the square root. Please take note, this is not square root. Okay, this is what you people use for your long divisions. Okay, the square root has a little bit of so this is how the square root looks like. Okay, now let's talk about one principle when it comes to using or dealing with square roots. Okay, square root basically means anything raised to the power half. Okay, so if I have the square root of what? A, what it means is that it's the same as a raised to the power 1 over 2, or a raised to the power half. Okay. Once we've established this, it basically means anytime I see a square root, I'll not panic. I'll not be so worried about it. And I could easily do justice to the square root. Okay. So let's see. Once we have that, I want to talk about something. Now, most of the mistakes students do is that if I have maybe that's not relating to the indices, but I just want to talk about it so that later when you are doing your calculations and other things, you have that knowledge and not make that mistake. So if I have A equal A squared equals C over D, and I'm to make E the subject, maybe I'll solve in some form of change of subject question or change of formula question. I get this, I get to this side, and I'm supposed to make E the subject. The square here can only be removed by applying square roots on both sides, not only one side, because it is an equation. Whatever I do to one side of the equation, you have to do it to the other side of the equation. So because I want to apply a square root, what it means is that once I apply a square root on the A, in order to remove the square, I have to apply it to this side. Now, what most students do is that they apply the square root all right, but when it gets to the second one, they forget that it is a fraction, and the square root is supposed to affect both the numerator and denominator of the fraction. So they end up not applying it to the denominator, but they just write the square root this way. This is actually wrong. Okay, the right thing to do is to put this way, d over d. So basically becomes, okay, so when you're applying the square root and it's supposed to affect one side, and that side is a fraction, and so you extend it so that it covers everything there. Okay. Now this square root will cancel, and I want to explain that principle quickly. If I have a square, and I apply a square root, and as I told you, this square root is the same as anything with the power of half. Basically means I'm applying half to this. Okay, the square root here means I'm applying half to the 2. And once I apply half to the 2, this will cancel this. And then the a will now become raised to the power 1. So that is the concept behind it. Not just because the square root is pretty, so we have to apply it to a square. But once you apply it, you are introducing half, and the denominator of that half will be able to cancel the the square. Okay, so once it cancels it, comes 1, and then technically you've gotten rid of that square over there. Okay, so that's just by the way. But the question I want us to look at, which is actually about the topic of the day, which is indices or powers of natural numbers, is this. So we have 2 raised to the power 8 equals root of 64. So this is a very simple one, but students will panic because they've seen the square root. What it means is that we have numbers called perfect squares. Okay, perfect squares are basically numbers that are obtained from a number multiplying itself. So 7 multiplying 7 will give us 49, which makes 49 perfect square. Now, when you apply raised to the power half, it basically means that if I divide that number into 2 equal parts, it will give me the same number multiplying it. Okay, so that's why we apply. When we apply a square root, we are able to split the two numbers, the two same numbers that are multiplying themselves to give us that big number. Let's split it. So when we look at it, 8 times 8 is actually 64. So it basically means that root of 64 is 8. Okay, root of 64 is 8, not root 8. Once you apply square root to the 64, the square root goes away because it's to be able to split the 64 into 8 times 8. Just have to choose 1. So basically this becomes 8. Okay, root of 64 or square root of 64 is what? 8. Once I have established that, then it basically means I have 2 raised to the power 8. Once I have 2 raised to the power 8, now the goal is from our very first example. The goal is that we are to quickly change the bigger base number because this is raised to the power 1, but we don't really write the 1 because 1 doesn't really affect it. So unless you are doing addition. So we are to change the bigger one, the bigger base number to have the smaller base number. Fine. Okay, so we just want to find out what will multiply 2 to give us. What raised to the power 2 raised to the power 1 number will give us 8. Basically, we've actually done that already. Our previous examples, and that gave us. So once it gives us 8, then we know that 2 raised to the power 3 comes 2 raised to the power 8 equals 2 raised to the power 3. And once the base numbers are the same, can actually make the powers do, okay, 3. So a is equal to what? A is equal to 3. Fantastic. So we'll continue. Now, for assignment purposes, you see, okay, let me just do one example before I even think. So yeah, so that's what we have. So the goal is to actually ensure that once we reciprocate, the negative is gone off. Once the negative is off, we are basically supposed to just get to a number raised to the power 3 that will give us 64. Another number raised to the power 3 that will give us 27. The number raised to the power 60 raised to the power 3 will be 4 raised to the power 3 that is going to give us 64. Okay, and then 27 is going to be 3 raised to the power 3 plus 27. Okay, so once we observe that, we are just going to replace those 64 and then 27, and then once it becomes what, how do you call it, 4 raised to the power 3 divided by 3 raised to the power 3. Okay. Why are we doing this? We are doing this because we have a denominator that is 3. Okay, so we have to do our possible best to change that denominator. Okay, change that denominator. So whilst we do that, we basically have to just get numbers that are raised to the power 3. But when we pull those indexes out, it can go and cancel the raised to the power 3 that we have there. So quickly, we are just going to do that. So this will become 4 over 3, 4 raised to the power what? 3. Now, this 3 coming out, these two 3's are coming out because I explained it earlier. So I'm not going to explain it again. But what it actually means is that if I have a over b raised to the power 2, this 2 is affecting the a. If I want to pull that 2 in the square inside, going to be this. Okay, so it's the same thing. And this time around, I'm just reversing it. I'm pulling it out. I'm not pulling it in. I'm pulling it out. So quickly, so it's just coming to multiply the fraction index we have. Okay. So once we have that, we know that this is a simple fraction multiplying a whole number multiplying a fraction. It becomes 3 over 1 times 2 over 3. This will cancel. This will end up giving us 2 over 1, which is the same as 2. So our answer is what? 4 over what? 3. 4 over 3, all raised to the power 2. Now, they said you should simplify it. So they actually wish that at this point, you are not going to just leave it that way. That basically you would do something about it. Do something about it in the sense that you go ahead and find the 4 raised to the power 2 and then the 4 raised to the power 3, the value. Okay, so let's do that for them. Once the statement or the preamble to the question is simplified, it becomes 4 raised to the power 2 divided by 3 raised to the power 2. That's basically going to give us 16, because 4 raised to the power 2 is the same as 4 times 4. 16, this is going to give us 9. Okay, now you can decide to leave it this way, or you can decide to change it to a mixed fraction. Changing to a mixed fraction, you just want to find out how many 9s you get in 16. Just 1. Okay, and 9 minus, since it's just 1, you do 16 minus 9, and that's going to be 7. And you have what? Your denominator being the password. So that's another way, but it's not really necessary to change it to what? Mixed fraction, unless of course the question specifically tells. So the 16 divided by 9, fine. 16 divided by 9 is perfect. Okay, it's perfect. So we're going to take our last 2 questions and then we are just going to call it a day. Okay, so just bear with me, be with me. Finish very, very, very soon. Okay, we'll be finishing very soon. So our last question basically is a simple one. It's a bit straightforward. So we won't really spend much time solving it. Okay, spend much time solving. So our last question basically, I'll talk a little bit about what this means. Okay. Now, what it basically means is that this is square root. Okay, so it's actually 2 times root what? 2. Okay, 2 times root 2 times root 2. Now, this kind of things, when we go to the SHS, is a full topic on its own. But sometimes in some of the past questions I've seen, especially in Agbogo, some of these questions are presented. Okay, especially the mock side of Agbogo. Some of these questions are presented. So it's actually good for you to know that when you have maybe A root B, the A and the root B, the operation between them is A times what? Root B. Okay, so that is the concept. So that's going to help us solve this particular question that I want us to solve. So the question, this is the question. So let me just write here. And it actually says a raised to the power x is what? 2 root 2. Okay, 2 square root 2. Okay, I've already explained the 2 square root 2. So we can just do the expansion quickly. So this is what it means. Okay. And we've also established that root of 2 or square root is actually anything with the power half. So we have 2, which is 2 is the power 1 times what? This becoming 2 is the power half. And we have our 8x. Okay. So now what it means is that we'll quickly have to, we don't have a choice, but we'll quickly have to try and get rid of what's the 8. Okay. We'll quickly try and get rid of it. But you see, one of the principles I made mention of at the beginning of the class, which is also part of what the rules when it comes to indices, that when you have a raised to the power x times what a raised to the power b, but a plus what. Okay. So once we've established that, that is, when we look at this side of this question, okay, or this equation, realize that we have the same what base number. We have 1 and we have half. So when we add, we should get 2 raised to the power 1 over 2. Those who are confused that why is it 2 raised to the power 1 over 2? If I have this whole number 1 over 4, the same as 3 plus what? 1 over 4. Okay, so if I have 1, okay, now becoming 2, 1 plus what? Half, the same as this. Okay, so don't be confused. Don't be confused. I'm sorry that I'm rushing it because of the time, but just take your time, come back and come and watch it free time when you have internet. It's really, really important so that you can clear this part of the syllabus and be confident about it. Don't worry about it. Because when it comes to indices or powers of numbers, you can actually complicate it in so many ways. So even though you understand the concept, if you understand how to apply some of this, you find yourself wanting. So that is why I can write what 2 raised to the power 1 whole number 1 over 2. Okay, because of the principle, the very first what rule that I explained to. And I also told you that a fraction, a whole number, a mixed fraction is actually a whole number being a fraction. Okay, so that is how come we had 2 raised to the power 1 whole number 1, 2. Okay, so once we have that, then we have our 8. Okay, so we've actually simplified this side. Once we are done with that, now we have 2 and we have 8. So the goal is to actually make 8 like 2. So we want to find out 2 is the power to give us 8. I think we've done series of that. We have said it over and over again. So if you know the answer, you can actually post it in the chat section or comment section. Okay? But I'll still go ahead and write it anyway. That's the funny aspect. So it becomes 2 is to the power 3. Remember the x is already there, so it multiplies. Okay, whatever is already there that the index is going to be should multiply. Okay, so now it becomes 2 to the power 1 whole number 1 over 2. And now you realize that the base numbers are the same. So we are now going to deal with the index, the indices. We are going to deal with it linearly. Okay, so it becomes this. So dealing with this, we'll quickly sorry about that. We'll quickly now change the mixed fraction to an improper fraction. Okay, so there's another question. Please, will you edit the part at the beginning? Yes, I'll edit that part off so that when you come and watch, you don't have to start from that side. So once the video is uploaded by YouTube, it will give me the opportunity once I edit that part when you come in. So you can come and watch it maybe tomorrow. By tomorrow, that part will be taken off and enjoy it. So once we have this, this becomes times plus, and that, let me bring this here. Sorry that the board is a bit clumsy. So this will give us 3 over 2. 3 over 2 in the sense that 2 multiplying 1 to give us 2 plus 1, 3. So 3 over 2. Once we have this, we are going to divide both sides by 3. Or the best thing you can do, is actually taking this 2. Okay, so take this 2 and send it to this. Okay, so now it becomes 2 times 3x equals what? 3. This will give us 6x equals. Okay, then now we can divide both sides by 6. Then cancel. Then this will give us, uh-oh. Okay, so um, I think there's something that the yellow thing there. I hope it has not blocked the thing so much that you can't see. But you can click on that, and if you've not subscribed to my channel, subscribe to it. That's the only way you can show appreciation. So let me just bring that answer here. Okay. So whatever was here was 2. Okay, whatever was that where the yellow banner is. Once I bring it, it becomes x equals what? Because 3 will go into, you're not supposed to cancel. So 3 will go into, that gives us x. Okay, so basically that is it for today. We are going to end here. You're not going to get any assignments, but when we meet on Monday, we might have a test basically on this. So please ensure you rewatch the video. If you want to watch it once, twice, 3 times, it's up to you. But ensure you watch it and understand every single thing that has been explained here. Because Monday, we are going to have a printout test. Okay? We're going to have a printout test. Why 4 over 7 over 2? Okay, so you're going to have a printout test on this particular topic. Okay, so ensure you rewatch and understand every single thing that is here. Okay, ensure you rewatch and understand everything. Thank you very much for being here. For those who are now watching, when you get to this part, kudos. Have a nice evening. Bye bye. You can take the rest of the 10 minutes and go on. Please, before you go, subscribe to the channel, like the video, okay? Like the video. That's the only way you can show appreciation to me. And also subscribe to the channel. Agent Blue Tag, subscribe to my channel. Have a nice day. Please ensure you learn because I've told you to go and do some form of, how do you call it? Oh, number plane, okay? Number plane. There's a reason I'm telling you to go and do that. So go and do that so that if a surprise test surfaces, you will not be chewing your pen. Have a nice evening. See you tomorrow. Bye. You are most welcome. And thank you too for being here. Okay? Bye. Adley, thank you too. Bye, Prince Ali. Bye. Thank you to Nadu Moham. Subscribe to the channel. Panche, thank you too. Bye bye. Agent Blue Tie, bye. Masupe, I know you come and watch again. You are doing very well. Bye bye. Ruben, you're not serious. We should use the rest of the 10 minutes for stories. What story? Unless some people are now watching, so don't distract them. Some people are now maybe at the middle of the lesson. That's why you can see them online, but it doesn't mean they've gotten to where we've gotten to. Okay. Okay, Ache, bye bye. I know Ache is Maxine. Who's that? Maxine. Okay, I don't know. Story. Harry, behave yourself. Okay, bye. Who is? Hey, you have some weird names too. Yo, bye bye. Bye bye. I'm going. Thank you very much, Adlet, for subscribing and liking the video. Thank you. Bye.